All right. Welcome, everyone. Thank you for joining us today. Today, in this presentation, we will explore the fascinating world of monorepos. So with that, welcome to Java-oriented monorepo, enhancing efficiency and collaboration. My name is Szymon Sadowski. I am a principal software engineer at Sabre, where I am a part of the platform engineering team, which, among many other things, develops the Monorepo solution and all of the tooling and processes surrounding it. So here is the agenda for this presentation for today. We'll start with defining what is the Monorepo, what are the pros and cons of using this approach. We'll take a look what advantages can it bring to Java development. And at the end, the goal is to help you make an informed decision if you should consider using this approach or not. So once again, let's start with this basic question: what is the monorepo? So the answer to that is pretty simple. Is monorepo is storing multiple projects inside just one repository. And you may say, wait a second, isn't it a horrible idea? It might seem like a horrible idea because as we start our career as software engineers, from the very beginning, we are taught those fundamental principles of keeping the code, isolated and modularized. So it may go against everything we learned to be right. But it turns out that many tech giant companies like Google, Uber, Airbnb, Microsoft, all of them use the monorepo approach to some degree. And the biggest example is Google, which stores around 95% of all of their code in just one single repository. So the question here is, what is the deal here? What is there to gain from storing multiple projects inside one repository? Why those tech giants do this kind of thing? And it turns out like with many things in life, it is like in chess. So as we start learning chess, we learn those basic fundamental principles that you should always strive to control the middle of the board. You need to develop your pieces as quickly as possible. But as you advance, you learn more and more. You start to study the games of the grandmasters. You see that they are breaking those rules all over the place, and they are gaining a lot of advantage from that. Which actually reminds me of one of my favorite Reddit posts ever. And it goes like this. I don't understand chess. When a grandmaster pushes their pawns, they have a space advantage and clamp down on their opponent position. But when I push pawns, I am overextending and creating weaknesses. So what is the deal here? Why tech giants can get away with breaking the rule of one project per one repository and gain advantage from that, and why Grandmaster can also break fundamental principles and gain advantage from that. So actually, it turns out that you can gain advantage from breaking the rules. First of all, if you are prepared and you know what you are doing and have the knowledge about what it takes to make monorepo efficient. So at the beginning of this presentation, let this be my promise for you that during this presentation, we will explore the advantages and disadvantages some things that you need to be aware of. And at the end of this presentation, you will have more knowledge when it is okay to break this rule, and perhaps if it's the right choice for you. And just to give some credibility to this experience that I'm sharing, I wanted to share a few statistics. This Monorepo solution that I am a part of developing here in Sabre has 400 unique contributors every month. Every month we run 1,000 CI builds. Every month we have around 3,000 pull requests merged, and our Monorepo hosts there's basically over 1,000 projects inside our Mono repository. So things like HTTP services, gRPC services, UI components, common libraries, and so on. We have over 1,000 of such projects. And also interesting fact is that it is very Java focused, because around 50% of the code there is written in Java. So also I will try to share some experiences how it goes with developing such Java focused monorepo. All right, so having said that, let's start exploring some advantages and what is there to gain from storing multiple projects per one repository. And to answer that question, why should you do that? Let me tell you a story. So the story goes like this. Let's suppose you are almost at the finish of a very long and tiresome debugging session. You think that you nailed down the issue exactly, you made a fix, and now you want to run all of your tests, which will take around 30 minutes. So you run these tests and you figure that you can go to the kitchen to grab a cup of coffee. So you go there, but it turns out that the coffee pot is empty. You reach to the cupboard to grab some coffee and brew new coffee, right? But it turns out that there is no coffee there. So you go to the supplies cabinet in the corridor, but it turns out that it is locked. You remember that Jack from the 4th floor has keys to the cabinet. So you go there, but on the door, there is a note that he is out of office. He's out of office, and in his absence, Janice from the building across the street stands in for him. So you go there, but it turns out that Janice doesn't have the keys. In the act of desperation, you text your friend, Samantha, and she responds that in the mini kitchen on the 3rd floor, there is a coffee bag that you can use. So you go there, you grab the coffee bag, you go back to your kitchen on the 1st floor, you open the bag. It turns out that the coffee is in beans, it is not grinded. So you find yourself in a situation that you need a coffee grinder. But unfortunately, there is no coffee grinder anywhere to be seen. So you come up with this idea to wrap the beans in a towel and smash it with a hammer. So interesting how we got there to make coffee. Now we are needing the hammer. But you decide to try it anyway. You manage to grind some coffee, but unfortunately the coffee filter in the coffee machine is old and soggy, and there is no replacement. So you give up and go to the Starbucks down the street. You go back to your desk, and it turns out that the tests are still failing. So what a day in the office. And this is a situation that may be strangely familiar to many of us. And this situation in software, we often call it the dependency hell. So it is a situation where you basically, through the convoluted mess of the dependencies, you end up needing to have a hammer in order to make coffee. And I can say from practice that it can happen. So once I was investigating some project, and I noticed that for making one-off simple SOAP request, the entire library of SOAP UI was imported, which is very heavy, a few megabytes. So that was quite a similar situation. Yes, so that's one thing that we can end up depending on some kind of ridiculous things, like depending on hammer for making a coffee. But also it is very, very difficult to manage so many dependencies in a clean way. You have all sorts of problems, like diamond dependency problems. So basically, managing dependencies in software is a really painful thing to do. And to me, actually, that is one of the biggest selling point of Monorepo, because it allows us to solve a lot of pain points of the dependency management. So first of all, our dependency management can be simplified via the use of bill of materials. So for instance, in our monorepo in Maven, we have a common POM XML file, which has a dependency management section for basically managing the dependencies and the versions of the dependencies that are using across all projects, and having all of the projects and this BOM bill of material inside one repository makes it really easy and swift to make any kind of changes, rather than publishing new BOMs and consuming them, bumping versions of the projects using them. In Monorepo, we don't have anything like that. We can just use the BOM that is there inside the common code base. So for instance, things like upgrading, the log4j dependencies when the vulnerability comes out really ends up being a change in one line, in one file, rather than, doing all of the hassle of searching through repositories and seeing which one is still using the vulnerable package. And there's also a set of benefits that come from using this common BOM. You will end up using the same kind of libraries and the same versions of the libraries in your project. So whenever there is some kind of a bug or something that you need to be aware of in a particular version of the package, you already have the expertise which you can share with the rest of the teams, so that they can benefit from that, and they can save time. So that is one thing, simplified management of dependencies. The other thing is that by having multiple or most of projects inside one repository, you can make it easy to consume internal libraries. So I think many of us know this pain that you want to consume some library from some team. Let's suppose it's some kind of utility library. You try the version 2.5 because it has some function that you need, but it turns out that this version has a security vulnerability. So you try the 2.6. For some reason, it doesn't have the function that you need. The 2.7 has the function, doesn't have security vulnerability, but it throws an error for some reason. In 3.0, everything works perfectly, but it requires upgrading a tool chain, which you cannot afford right now. So many times we'll end up in such kind of a situation where you just want some kind of a version that works and you struggle to find the right version for you. So with Monorepo, this problem is mitigated because you consume the library straight from the same repository. So in practice, it might look like for Java, rather than building and publishing your internal packages to some kind of package manager like Nexus or Artifactory, and consuming from other projects those packages. What you can do is you can build and install those packages just to the local M2 repository straight from the code base, and you will always have the latest version, which is not versioned, so you don't have to wonder which version you need to choose, and also you won't have to wonder, like for example, what code is there in the production. The idea is that you always use the version that is there on master. If you need to if some, let's say, feature is still in development, you can use the feature flags to disable it. But at the end of the day, you are running the code that is there on master on production, and you don't have to wonder. So that makes it easy for consuming libraries. And also, as a publisher of the library, your job is simplified, because if you want to provide some library to the rest of the company or to a different team, then if you are doing that, providing this library to other teams, if you want to make some kind of a change, you don't have to, wonder who are you going to break with this change. You don't have to, find out that you made a change and 2 weeks after some teams talks to you that the update broke them. So it can be really painful to deal with that. And in the monorepo approach, this problem is also mitigated, because having everything in one repository, your build tool will tell you what are the dependencies between the projects. So you don't have to wonder who is depending on your project, and having the same CI/CD process for all of the projects in the monorepo, you will straight away know if you are breaking anyone with your changes, so you can do the necessary adjustments right away, and you won't have any surprises later on. So that is the very big advantage. So we established that consuming and publishing libraries in monorepo is simplified, but we need to be aware that there are some trade-offs related to that, because if you are making it so easy to consume and publish libraries, one day you may end up in a situation that you are making some change to a prototype project, and seeing that you are breaking 500 other projects, and you never intended even for anyone to use this project. So that's where the mechanism of API visibility comes in. So in many state-of-the-art tools for building monorepos, like for example, the Bazel tool, which allows you to build projects in the same fashion for multiple languages, there is an inherent mechanism of API visibility. So like we can see on the screen, we can specify that, hey, for this particular package, I want the visibility to be private. I don't want anyone to depend or consume this library. Or if there is a certain group of people that we allow to use our library, we can specify in this kind of fashion. So yeah, this is the solution to that problem, and generally, this kind of explicitly showing the API visibility encourages a good dependency hygiene. That every time someone consumes the library, there needs to happen some kind of a discussion if it's the right idea, and if I should allow someone to use my package. So that is a really great benefit by encouraging this dependency hygiene. The second advantage of Monorepo is the possibility of making atomic commits. And what I mean by atomic commits is that rather than doing some, large scale changes that touch multiple projects, multiple repositories, rather than, submitting multiple pull requests, coordinating with the teams, learning their processes for code review, for learning the CI systems. Rather than doing all of that, we have just one repository where we can make one perhaps giant pull request which does all of the changes, and we can merge them all at once. So it can also yield great benefits for situations where we want to avoid coordinating, complex changes. Like, let's suppose you want to change some authorization mechanism between service A and service B to a different method. So in a standard scenario with different repositories, different release cycles, when the release cycle is different, you might end up in a situation where you need to do the entire analysis, which change goes first, and if you need any kind of backward compatibility, just to throw it away after a couple of days or weeks. With Monorepo, you can merge such kind of a change in one go. And guess what? If you have Monorepo and this single CI/CD solution, you will release all of those changes at once as well. So you won't have to pay the additional cost of implementing any kind of backward compatibility. And I can say that it works very, very well in practice, especially in situations, for example, for large-scale refactorings. So speaking from experience, recently I was a part of efforts to migrate or upgrade all of Spring Boot services in our Monorepo from version 2.7 to 3.2, which has a lot of breaking changes and also requires an upgrade of the major upgrade of the Java version. So in the standard scenario, doing such change will also be very painful because you will have to coordinate, you will have to plan a lot, so that if there are any dependencies between the libraries, also needs to be coordinated. But with the Monorepo, we will able to do our changes in the background while the teams were doing their usual operations. We prepared the changes necessary to upgrade from 2.7 to 3.2, and we were able to push them all at once via single merge. And in the end, it saved us a lot of man hours because we didn't have to do this planning across many other teams and all of this coordination. It happened only inside one team, just one planning activity, and no overhead of the coordination was needed. And also, while we were doing this migration, we learned some common cases for how to fix some problem where there was a breaking change between Spring Boot 2.7 and Spring Boot 3.2. So I can say that those large-scale refactorings work very well in practice and are one of the biggest advantages of the monorepo. So with this kind of atomic commits, we can have some challenges because it may be difficult to read a giant pull request, but also we can mitigate it by using the code owners approach, where you specify which person, which team is responsible for which directory in a certain repository. And you can do this kind of incremental commits where in every commit you, in an incremental fashion, you present to the reviewer the changes so that it is easy for him to understand. And the third advantage that I wanted to mention of the monorepo is that it is easier to have consistency and standardization. And what I mean by that is that we can keep the similar structure of your projects. For example, we can provide some code generators where you can initialize a new project in your repository, in your monorepository, in the same kind of fashion. And from practice, I can also say that it is very, very beneficial to have this similar kind of structure. Like one anecdote that I can share is that there was one time where I had to upgrade some Kubernetes deployment definitions in order to adhere to a new security policy. So I had to add the security context to the definition. And by having this similar structure of the projects, I was able to prepare an automated script, Python script, which went through all of those files and applied the necessary changes, once again saving everyone time. The next advantage is that we can define a common development environment for everyone in the monorepo and have it the same as in CI CD. So we use Nix for that purpose. It allows you to create reproducible builds, reproducible environments. So it's easier because you won't have to like debug that something happens differently in the CI as on your local, and also between developers they will have the same tool chains, the same tools. So there won't be any divergence there, and you won't have to debug if there's any difference between the tool chains. And also you are making it easier to move across teams or making contributions across the teams, because if you have the similar structure, similar processes, like for example for the code review, similar linting rules, similar pre-commit hooks, similar libraries, then even if you are making a change to a completely different team, it still feels familiar and you can get up to speed in no time. And also you can make the contributions across other teams if you need some kind of a change, then rather than going through the hassle of getting all the necessary permissions, cloning the repository, you can just easily submit a pull request and make a change in a different team's project. So this kind of a inner source is approach is encouraged in the monorepo. Yes, so the same formatting, linting, as we said. The CI/CD will be done in the same way, having just one single solution. So also we will save some effort here because you will do this once. Of course, it's going to be more complicated, but at the end of the day, you are consolidating and saving duplicate effort. And as we said earlier, we'll use the similar libraries via common bill of materials. All right, so those were the advantages that I wanted to share. Now let's see what are the challenges of the monorepo. So first of all, the build time is something that we need to keep an eye on because in the monorepo, the CI build time can get out of hand if we are not careful. Because for starters, we will have a very large repository, so cloning will take a lot of time or more time than usual repositories. All of the logic of the CI/CD pipelines that are necessary to make it one size fits all will also add to the build time. But in order to mitigate this, we can use the right set of tools. So, like I mentioned, for example, Bazel is one tool that is commonly used for building monorepos, and it has a high degree of caching and parallelization, which allows the builds to still be quick, even though we are building a massive amount of code. It is necessary to have some mechanism of building only affected projects. The naive approach is to build everything as you start the monorepo, but as you scale up, you will have to find a way to build only affected projects. But the tools like Bazel have some mechanism to determine that for every commit, for every change, you are able to determine which projects were affected. Of course, you will have to keep your processes and algorithms optimized and ensure scalability. So here in our case, we are doing this by running our builds in Kubernetes cluster on GKE. The next challenge is how to handle top secret code, because there might be a situation that you have some kind of a business critical code or some trading secrets that you don't want too many eyes looking on. So what can you do in that case? Unfortunately, in the standard version control systems like Git, there is no an easy solution for doing that. There is no like granular access control. You can work around these problems by using some Git submodules or Git subtrees approach, but at the end of the day, you won't have a good time with it. There are a lot of problems with those workarounds, and at the end of the day, you are going against the fundamentals of the monorepo, which encourages the openness and collaboration. So if you have a lot of top secret code or you want to have this kind of access control, then the monorepo approach won't be good for you. And the next challenge is the complexity and friction, because if you introduce complex tools for making the monorepo efficient to handle this large code base, a lot of developers will be unhappy with that. They may not be familiar with those tools, or they may prefer more standard tools commonly used in the industry. So it is an important realization for me. It was shocking first when I started that some of the best developers were saying that they don't feel productive in this monorepo environment, that without the overhead of those tools and these processes they could move much faster. So it was really surprising for me, but then came an important realization that the goal here is not to move faster on the individual level, but to move faster as a whole organization. So as long as we are moving quicker as an organization, that is the advantage. So it is important to realize that in fact, some of the teams, some of the developers will say that this approach is making them slower. But as I said, as long as we are moving quicker as an organization, this is still a very big win for us. All right, so having explored those advantages and disadvantages, I wanted to share some lessons that we learned by doing this monorepo development. And the first lesson is to keep your code healthy. So always try to have the builds, deterministic and always passing. Do not allow any situations where the builds of services are failing on master for whatever reason. And have also stable tests and sensible tests that are testing in a good fashion your application. And why do you need to do that? Is because this allows us to do those kind of great things like large scale refactorings. If the code is not healthy, the builds are failing sometimes, or master on, or the tests are unstable, flaky, like passing one time but failing the other time, then when I'm doing this kind of change, like upgrade to a new version of Spring Boot, and the tests are failing, but they are expected to fail, or that some kind of test is, failing one time but passing the other time, then how do I know that I'm not in fact breaking anything? I need to have a clear signal that I'm not breaking anything with my upgrades. So if we can keep the code healthy and have good tests, then we can really utilize those full advantages. And the next point is kind of goes hand in hand with the first one, that if the project doesn't have any tests, then this is not a good fit for the monorepo, because you won't have any benefits. You won't be able to determine if your like large scale changes are breaking this project or not. The next lesson is that you don't have to go all in, and this is when I was doing research, kind of a common consensus in the industry. Everyone recommends, and I also recommend, that you can start small. You can pick the projects that you are going to place in your monorepo carefully. You can only choose those projects that are fulfilling those conditions for having the healthy code and tested code. And you can scale as you go. You can work your way up. And that is really a sustainable way in order to scale up your monorepo. So be aware of that you don't have to go all in. You can start small and work your way up. The important realization is that you need to provide trainings for the tools that you are introducing. And it is, and you need to be aware that at the beginning, if you are introducing the monorepo, the projects that are going to be inside the monorepo, the developers in that project at first, they for sure will have a productivity dip. They will have the productivity decreased for some time because they will have to adjust to this new way of working. They will have to learn those new tools. So you need to be, aware that you will have to provide those trainings, and because at the end of the day, you will have the most expertise in those tools while you were setting up this monorepo. So you can transfer your knowledge to ensure that this productivity decrease quickly turns into the productivity increase. And you will have to provide good support because, and by support, I mean in the cases that something, let's suppose in the CI/CD, there is a problem or something like that, you will have to be proactive and fix those kind of issues as soon as possible, because this is an important realization that this monorepo platform would be another dependency for those teams. So if they will be waiting a long time for you to fix something in the CI/CD, then they will lose precious time. So it is important to be as quickly as possible with supporting this monorepo platform. And also, one of the lessons that I learned is that some tools do not work well with the monorepo, at least not yet. So just to give you an example, for example, in the Bitbucket, we found that challenging to work with the monorepo in the Bitbucket Git repository, because the functionality for builds API for pinning the build statuses to pull requests, it lacks certain functionality that would be really beneficial in this monorepo approach. So it is a good idea to do your research and see what functionalities you may need. So actually, I can share that we are migrating from Bitbucket to GitHub, and then there on GitHub we found that the capabilities are more available for the monorepo approach. So I advise to do the same kind of thing and do your research. So as promised, we'll explore some monorepo advantages for Java. So as we said, the common bill of materials will ensure that you can just control the dependency version in just one place. And by using the same suite of dependencies and versions, it will be easier to share the expertise and fix any kind of errors. And debugging is generally much simpler in the monorepository because having this common structure and source code available. So from practice, I can say that during this Spring Boot upgrade, I had to debug a lot of failing tests and so on. So I had all the source code right in my IDE, so I didn't have to clone the repositories, switch over there and see the code, or even during the navigation in the debugger, I have the source code, so I don't have to download sources or anything like that and choose the source location. And also because of the fact that the deployments were similar, I was able to apply the same kind of debugging techniques, like for example, connecting to the Kubernetes pod remotely and investigating the tests in the same way. So I can say that the debugging is really, really simplified. so as we said, we won't have the dependency hell, which is a particular nightmare. Not only in Java, but in Java it's also very prominent, and we'll ensure this dependency hygiene between the projects. All right, so just to fulfill that promise that I made at the beginning, that at the end of this talk we will know what it takes or what's necessary to know before breaking this rule of one project per repository, so that we can be like those grandmasters in chess who also are aware when to break the rules. So if you have a lot of top secret projects, or you have to apply some kind of access control, then the monorepo probably won't be a good fit for you, because at the end of the day, you will be going against the entire idea, the fundamental principles. So I don't recommend the monorepo approach if you have this a lot of top secret projects or some projects that you want to hide. If your projects are healthy and have tests, then definitely Monorepo can work well for you. If you use various technology stacks, it may not be a good idea for you to use the Monorepo, because ensuring the support in those complex build tools, like for example Bazel, can be difficult even for just one language. So if you have a lot of languages, then it's gonna be difficult. I would say you need to pick just a few languages, few technologies that you want to support and support them well. And that's where then the Monorepo will be efficient. And you need to consider if your organization is ready, because you will have to invest in some team of engineers who will work on the Monorepo, and also you need to be aware if your organization is ready, in the sense that there will be, open collaboration, no boundaries, and a lot of sort of inner source work, and also if your organization is ready to adopt those complex tools. So if you consider that your organization is ready for that, then for sure you can decide to try this approach. So as we end this presentation, right now we are more knowledgeable and we have the understanding what it takes to break those rules and gain advantages from breaking the rules, just as the tech giants in the IT industry are breaking the rule of one project per one repository, and also just like the grandmaster in chess who gain advantage by breaking fundamental rules. And now we also know when it is okay to break those rules. So with that, let's see if we have any questions. All right, so the question is how, in my experience, the collaboration changes where we work in the Monorepo versus working in the Poly repository. So there are a few things to consider. So from my experience, the collaboration is a lot more encouraged in the Monorepo. just to give you an example, like this is an opinion that I've heard from a lot of people that are working in projects that are in our Monorepo, is that previously you had this, boundaries that when you saw something, something incorrect in other project, you will go to the developer of that project and say, hey, can you go ahead and fix that? In the Monorepo approach, it is much easier, to avoid that, and just, you already know what what what's there that is incorrect, what's there that's bad. You can just, submit a pull request very easily, send it to this other person, and that way you can make improvements. So this is a kind of a model of doing the inner source, where we can, make changes across many different projects. Also, the other thing that changes is that a lot of this overhead that I mentioned, like for example, all of this planning, all of this collaboration is decreased. So this really saves us a lot of time in terms, of this coordination and communication. So it ends up being that you can, as a developer of, the product team, you can focus more on your day-to-day work and delivering the business value, rather than doing the hustle of upgrading libraries, or resolving the security vulnerabilities and so on, right? So it also encourages the teams to develop expertise, so that the team that is in the platform engineering, let's suppose, who are developing this Monorepo solution, can get develop a very great expertise in CI/CD, whereas the product teams can be really great in doing the application development, and they don't have to invest time in learning that much of CI/CD. So I'd say that are the most prominent changes that I observed. So the question is how we deal with managing the dependencies in Monorepo to avoid conflicts between different projects in Java. So there can be a lot of conflicts that may happen in Java. So particularly, it can happen when we have this diamond dependency problem, for example. So I observed it a lot. So for example, in Maven, we will get the error in the reactor that we don't know which version of the dependency to choose at the end of this diamond dependency, but it is all resolved by using this common bill of materials. So like I mentioned, we have a common bill of materials where in one POM XML file, we define in the dependency management section all the suggested versions of the libraries, the consolidated versions, and that way every project that is so we can specify that this common bill of materials, this common POM XML file, is a parent for every project in the monorepository. So that way it will inherit this dependency management section, and there won't be conflicts between the projects because already the versions are consolidated. and we also need to ensure that that the dependencies that are chosen are from the same kind of ecosystem to avoid any surprising conflicts. So like we are particularly in the Spring Boot world, so we tend to use just libraries that are recommended by Spring Boot, and this really um, helps to decrease the conflicts. So, like just for example, one time we observed conflicts where some projects were using some custom gRPC libraries for gRPC server and clients, but the problem disappeared when we migrated to some kind of a library provided by the Spring Boot, because they already have this the right version that are not conflicting. So that is the good approach, I would say. Okay, so question is if there's any specific optimization that we had to introduce to the build process or testing process. And yes, there were certain optimizations that we had to do. So one such example is that in one of the slides I mentioned that we need to build only affected projects. So like I said in the beginning, you may find yourself wanting to build the entire Monorepo, all the projects, but after you scale up, this becomes not feasible. So in our case, we had to introduce some kind of a mechanism to determine which projects are affected by a particular change. So it ended up being another step in our CI/CD process for building and testing applications, that the first process determines which services needs to be built, and then for each service there is a separate job for building that. So that was a specific optimization, and also everyone had to learn what this first step was. So that was kind of interesting, but at this point everyone is very familiar and knows right away what this job does. And let me think if there were any other optimizations. Like the optimizations that we made also were, like I mentioned, we use Bazel, so we constantly check if our Bazel cache is utilized, because this is a tool which really only works good if the caching is achieved. So we constantly monitor if the for some reason the cache is not used when it should be, or something like that. So by constantly checking that, we are able to keep this process optimized. It looks like we have 1 minute left, so that's last chance to ask any questions. Okay, it looks like there is no further questions. So thank you very much for attending this presentation. I want to inform you that the recordings will be available on Facebook and YouTube. So once again, thank you very much, and have a good day.